हेलो गाइस, वेलकम यू ऑल टू एआई की पाठशाला। एआई की पाठशाला आपकी अपनी पाठशाला है एंड वॉट एवर सेशन आई एम कंडक्टिंग हियर, इट्स completely free of cost. So any one of you who wants to join my free live session, you can go to the description section of the video and join my Telegram group from the link attached there, because I send the group joining link in the Telegram group only. So by joining the Telegram group, you can have an access to my free live sessions. Today is the second session in NumPy, and whatever we have covered yesterday in the session 1, we will start from there. Whatever the last thing that we have covered, we will start from there and we will continue and see how much we can cover today. So let me first share you my screen. So I am going to share you my screen first. So let's share you my screen. So I suppose my screen is visible to you. Fine. So let's do one thing. Fine. Let me open my VS Code. So today I have already created one basic NumPy _1. Oh, okay, this is the session of yesterday. So let me open the today's session. That's NumPy 2. So this is the today's session. I've already created a GitHub repository and cloned that repository here. So now let's move ahead and let's see what we can do here. So what was the last thing that we have done yesterday? Can you please tell me, Varun? What was the last?
सर हमने बेसिक्स ऑफ सर वी डिड द बेसिक्स ऑफ अरेज। आपने बताया था 1D 2D 3D अरेज, फिर आपने मेथड्स बताए थे कुछ।
करेक्ट। लास्ट में हम लोगों ने random np.random.rand and np.random.random.randn किया था ये।
यस सर।
Now today we are going to do the basic data types. We are going to do the basic data type. Let me write it here. Let's write basic data types. Is my audio clearly audible? Am I clearly audible now?
यस सर।
Okay,
यस सर।
fine. So one thing that we have done yesterday was, if let's say a is, if I create one array np dot arrange, arrange, this is the way we used to create the array, and let's say if I give 10, so the array will get created. We have learned this thing. Now if I want to check the data type of this array, same thing we have studied in the Python, the data types. What are the data types? Int, float, string, and all those types. In the same way, we can also check the data type of our data type in NumPy. So we have created one array np.arange 10, and it will create an array, and I want to check the data type. So a.dtype is the right method to check the data type. And if I run this, okay, let's pardon me, actually I have not imported NumPy. So let's first import NumPy. Import NumPy as np. Fine. So whenever you do, you will start, you have to first import the NumPy. So I have imported NumPy here, and if you can see, the data type is int 64. That means it is This is a integer data type. Fine. Now, you can explicitly specify here which data type you want. See, I have, while creating this array, I have not specified any data type here. So by default, it has created an integer data type. That's why I am getting int 64. But you can explicitly specify here the data type. How you can specify? You can write np dot arrange, fine, and inside that this 10 comma, after this 10 you have to specify d type, and inside this you have to specify your data type. Let's say I want to create my floating point value, data type float. So I have to write float float. Let's write 64. So if you specify this thing, and now if you will create this array, and then if you can check, let's first do one thing. Let's check this array A. So can you see my array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the values inside is integer. Now I'm going to create an array in which I have specifically explicitly mentioned that my data type is float 64. Now if I will run this array, and let's also print this. So for printing, I am writing this, specifying A here. If I run this, I may get here 0 point, 1 point, 2 point, 3 point, 4 point, 5 point, 6 point. Can you see the difference between this array and this array? Only thing is, this is all the elements inside this array is in integer form, and all the elements inside this array is in the form of floating point value. Fine. So this is how you can specify the data type. Whichever data type you will specify, that data type it will create. One important thing is that, let's say if I want to create one data type, the default data type is, let me write this thing for you. This is very important. The default first data type, default data type is float for zeros and ones function. Fine. So this is the default data type for zeros and ones function. Now let's see, if I create one array A, and if I write np dot zeros, we already have learned that yesterday, and inside this array, if I want to create 3 rows and 3 columns, let's suppose if I want to create 3 rows and 3 columns, and I want to see, let's print A, and then I also want to see the data type. So A dot D type, type. If I run this, let's see what happens. So since this is np dot zeros is a 3 and I have mentioned this 3 comma 3 row and 3 rows and 3 columns, so I am getting here an array of 3 rows and 3 columns, and I have not mentioned any data type here. By default, data type is float. So it is taking, you can see 0 point, 0 point, 0 point, every element is in the form of floating point value. So the default data type is float for zeros and ones functions. And if I am checking here a dot d type, I am getting the data type float 64. Similarly, in the same way, you can check for ones also, and you will get the same thing. So let me copy this entire code and paste it here. And instead of this 0, just change it to ones, ONES, and just run it. You can see you are getting 1 point, 1 point, 1 point everywhere, because the default data type is float for zeros and ones functions. So this is all. Now let's understand some other data type also. There is a very this is not most commonly used data type, but it finds its function maybe somewhere. So this is a complex data type. So how you will create a complex data type? So let's write D and let's create np.array. And for creating a complex data type, you have to write a complex number. So you have to write a complex number in the form of a list, because a pair of value will come. Let's write a complex number, some 1 plus 2j. Let's write 2j, and then 1 plus comma, then write 2 plus 4j, 2 plus 4j. Fine. So this is a complex data type. Since the value I have given here, complex value, you must have understood this complex number and complex thing in, I suppose, 7 or 8 or 9th class. So this is all. So this is a complex data type. Let me write here, complex data type. Now let's print d dot d type. If you will simply print it, you will get, can you get? I am getting the data type of this D array as complex 128. That means this is a complex data array. This array is in this, the data type of this array is a complex data type. Now, another type of data type you have already studied in the Python, that is the Boolean data type. We have also studied about the complex data type. Let's understand it in NumPy. So let's write np.array, and inside this array, I am supplying it with some Boolean values. So let's write some Boolean values. Let's write true, comma, then let's write false, comma, then write again, let's write true, comma, then again write false. So this is the Boolean data type. This is my Boolean data type. Boolean data type. Fine. Now, if I will print the data type of this, let's print b dot d type. If I will simply do this and run this code, what I am getting? I am getting bool. That means the array that I have created here is in the form of Boolean. The data type of this array is Boolean. The data type of this array is Boolean. That means each one of the elements inside this array is in the form of Boolean values. Now, let's see if I will take some thing like, let's say if I will take this thing and I want to create one array np.array, and I'm putting some string values inside a list. Inside a list, I'm passing some string values. Let's pass the first value by the name Varun. Let's pass the second value by the name Anup, and let's pass the third value by the name NSUT. Let's say, fine, Varun, Anup, NSUT. And if I simply will check the s.d type, if I will simply do this, and let's run this and see what I am getting. I am getting D5, data type is less than U5. It is getting U5. What it means? Each built-in data type has a character code that uniquely identifies it. Let me write this thing. Each built in data type has a character code that uniquely identifies it. So if you will go to the, I am giving you certain few data types that I am providing you. Let me give you few data type, such thing, and the rest you will get, and the rest thing, let me see. These are certain things. That is, B stands for Boolean, I stands for signed integer, U stands for unsigned integer, F stands for floating point, C stands for complex floating point, M stands for time delta, capital M stands for date time, O stands for Python object, S and A byte string, U stands for Unicode, V stands for raw data or void. So these are some of the representations, character representations of the data type. See, these are some of the character representations of the some built-in data types, and rest you can see. If you will go to the I will show you. If you will go to the official site of the NumPy, if you will visit the official page of the NumPy, there you will get a list of all these things, the built-in data type that is present inside the NumPy. You will get a complete list of it. So you can see the list from there. So whenever you need, in general, you will need these data types in general use. But whenever if you need, you can always go there and see the built-in data type. The complete list is available there. So now this is all clear. Now I'm going to discuss a very important thing that we have already discussed in Python also, indexing and slicing. This is called indexing and slicing. So let's see one by one. Let's write one. First, create one array. Let's create one array, np dot range, and let's create this array. Fine. And first create this array. So this array has been created. This array is range from 0 to 9. 0 to 9. Now, let me tell you first one thing. The same thing whatever we have studied in the Python lists, Same thing is applicable, nothing new is here in terms of slicing and in terms of. So if any array is there or if any list is there, let's say this is for your, let's say I have this array. Let's say this is one, this is one, this is my array. Let's say this is my array 10, 15, 7, 9, 3, 5. This is my array. So how we used to index it? So the first, we will always, the indexing will start from the 0th position. So this is my 0 index. This is my first index. This is my second index. This is my third index. This is my fourth index. This is my fifth index. This is the way we used to do the indexing in our list also, and inside this array also we used to do the same. We used to do the indexing in the same way. So if you will see here also, the indexing will be like that. This is 0 index, this is 1 index, this is 2 index, this is 3 index, this is 4 index, this is 5, this is 6, this is 7, this is 8, and this is 9. Indexing will start from 0. Now, if I will ask you to give me the in this array A, give me the value of this at index 5. So what you will do? You will write A 5. This is an index position. This is an index position. So if you will do like this, it will give you the value at the 5th index. And what is my value at the 5th index? 5 is my value at the 5th index. So it will give you this value. Now let's do this same thing. So A, I want to access. Let's print also, print, because A, and at 5th index I want the value of what is my, so I am getting 5 here. If the array will be something different, then I will get something different value. So this is how the indexing works in my array. Now this is a case of one-dimensional array. This is a one-dimensional array. But let's say if I will have a two-dimensional array or multi-dimensional array. So in that case, in case of multi-dimensional array, let's say in case of 2 dimension or 3 dimension or any number of dimensions, how I will access the value at any particular index. So let's first create one multi-dimensional array. That is, let's create some multi-dimensional array, and then after that, let's try to access the value at any particular position. So we have studied about how to create a diagonal array in which we used to specify the value at the diagonals. So let's create one diagonal array or matrix, whatever, DIAG, and I want these values 1, comma, let's say 2, comma, let's say 3. I want these values at my diagonal. So what I will do, and let's see first. So let's create first. So this is my array. 1, 2, 3 is the value at the diagonal of this array. Now let's suppose I'm telling you to give me the value. Okay. So I am telling you to give me the values at the position, let's say 2, 2, a 2, 2. What it means? This 2 is my row at second row and this 2 is my column. Or I am asking you to give me the value at second row and at second column. So what is this? This is my which row? This is my 0th row. This is my first row. This is my second row. Now let's say column. So this is my 0th column. This is my first column. And this is my second column. Fine. What I am asking you to give me the value at second row. This is my second row. This is my second row. And at second column. So where these two values is getting intersection of these two, this is the value. This is the position which is second row and second column. This is my index position. This is my position 2, 2. Why this is my position 2, 2? Because this is the second row and second column. So I want the value at this location, at this index, which is at my second row and second index. So what is my value here? 3 is my value. So what I will get? If I will access this, I should get 3 here as my output. Now let's run this code and see if I am getting the same thing or not. Let's see here. A 2, 2. Fine. And I also want to print, let's see. I'm getting this 3. Fine. Because 3 is the value. Let me tell me what is the value at 2, 0. Varun?
Sir, 0.
0?
Yes,
Fine.
sir.
And what is the value as 1, 1?
Sir, 2.
Fine. Okay. This is the value at 1, 1. 2 is the value. So hope you have understood this. This is the way we use to access the value at any. Let's say instead of this is my 2-dimensional array, because there is a row. Let's say this we have a 3-dimensional array. So in this case, we will also give the third dimension. Let's say we have an n-dimension array. So we have to give the n number of dimensions. So at whichever dimensions you have to for n dimension, it is very difficult to, it's not even possible to think, but till 3 dimension we can able to think and we can able to visualize the things. Now let's understand one thing. Let's say in this array that we have just now created, this A, if I want to assign certain value at certain position, what is the value at my position 2, 1? A 2, 1. What is the value at 2, 1? So this is the value. 0 is my value at 2, 1. What is my 2, 1? 0, 1, 2 and 0, 1. So this is my position. This 0 is my position. And in here I want to assign something else. Let's see, let's say I want to assign some other values and I want to assign this value. Let's suppose 2, A 2, 1 is equal to, let's say 5. Let's put it. What I am doing? I am assigning values. ZNING, assigning values. Value. If I will do this, so what will happen? At this position, at this location, where there is a 0 at 2, 1 location, it will assign this 5. So what will happen? This value will get replaced by this 5. So if I will run this will happen. Now if you will again access this A, if you want to see A, let's see. Can you see here 0 has been replaced by 5, because at this position I have assigned this value 5. That's why this has been replaced. Similarly, at any position you can assign the value, whatever value you like, you want, you can assign any values at any position. So till here, any doubt? Now let's understand slicing. S-L-I-C-I-N-G, slicing. So how slicing works? Exactly the same way slicing works, whatever we have learned in the Python, basics Python, in the lists. Same thing works here also. So let's create create one array, np dot arrange, and let's create this array, and let's type this. Fine, I got this array. Now how slicing works, let me first write this thing, and then let's say if I will write 1 and 8, and let's say if I write 2, what it means? It simply means start index, end index, and index, and this is step size. Now what is this? So see, this is called a start index. First thing is called a start index. Second thing is called end index. And this last part is called step size. That means in this array, if you will do this slicing operation works like this. If you will give whatever index, this is an index value. This one is the index, is the starting index. So whatever index value you will assign here, you will write, it will start from that index. Let's say here I am giving the index value 1. So what is the index here? What is the index here? This is an index. One index is here. So it will start from this value. And what is the end index? 8. This thing. But the end index is not included. So this index is not included. Fine. So start index is in the end index, whatever be the end index, it is exclusive of it. End index is not included. So one index before it get included. It will, and this is a step size. That means I am asking it to jump. This is a jump size or step size to jump by 2 steps. So this is my starting index. If it will jump by, so it will come here. This is the next index. Again 1 jump, it will come here, 2 jump. Again 2 jump, first, second, it will come here. And after that it will not jump because it has to go. This is the last index, because my starting it will not this index is not included. 8 index is not included, only till here it can cover. So it will find, it will, if I will apply this slicing operation here, I shall get this thing 1, 3, 5 and 7. This is my final value. So this is how the slicing operation actually works. And in the same way the slicing operation works in list also. So let's check it out by with the help of code. Let's run this and see what happens. I am getting 151357. In the same way, you can, let's say, instead of this thing, if you can write A, and if you can write, let's say, 5, this thing. Simply, if you will write this thing, what it will give you? It means we have not given the end index, we have not even given the step size. If you will not specify the step size, it will take the default step size of 1. But here I am only mentioning the starting index. Start index is my 5. This is my start index, and thereafter I am only mentioning this colon. So what it means, it will start from this index and it will go till end. It means that if there is nothing after colon, it simply means I am asking it to start from this index, 5th index, and go till the end index. So it is starting from this 5 and going till the end. So my end is 9. So 6, 7, 8, 9. Similarly, if you will write, let's say, if you will write A here, and you will simply write colon, and after that, if you will write, let's say, 7, or let's say, okay, fine, 7, and if you will run this, you will get 0 to 6. What it means? It simply means I have not given my starting index. So since I have not mentioned my starting index, so it will by default it will start from 0 index. It will start from 0 index if you will not mention any, and it will go. This is my end index I am mentioning, but the end index is not included. This end index is not included, so it will give me one index less than my end index. So it will start from 0 and it will go till end index minus 1, and index minus 1, because end index is not included. So it is starting from 0 and it is going till end index minus 1. So I am getting 0 to 6. If let's say this, I am taking one more case here. If let's say I will simply mention this thing colon, what it means, and if I will run, I am getting 0 to 9. What it simply means, I am asking it to start from 0 index and go till end if I am not mentioning anything. And by default, the step size is 1. Fine. Now, let's take one more variation in this case. Now, let's say I am asking it to go from my first index to the last index, and thereafter, let's say I am giving step size 2. What it means? What is the meaning of this? Let's understand. It simply means that, let's write it here. Okay. Not this thing. So it's simply, if I am writing this thing as this, and this, what it means? See, I have not mentioned anything here. So it will start from, this is my starting index. It will start from 0 index, 0 index, 0 index. It will start. And this is my end index. I am not mentioning anything. So it will go till end. Till end. And this is the position of my step size. Step size. This is the position of my step size. So what will happen? It will start from a 0 index and it will go till end, but it will go in a step size of 2. Whatever step size I will give. So see, let's see here. It will start from the 0 index and it will go till end. My end is 9. So it will go till end. But it will not go in a step size of 1, default step size. It will go in a step size of 2. So it will go from here to here. Then it will come from here to here. Then it will come from here to here. And finally, it will come from here to here. And after that, if it will jump, it will cross it. So it will not, and here nothing is there. So finally, what I will get? I will get 0, 2, 4, 6, and 8. This is the array that I will get if I will write like this. So let's run this and see, am I getting the same thing or not? Let's run this. Let's run. Can you see I am getting 0, 2, 4, 6, 8. To solidify our understanding, let's, instead of this 3, let's write 4 and see what happens. I am getting 0, 4, and 8. Because this time it is going in a step size of 4. So my first value is 0, second is 4, third is 8. After that, it ends. So this is how this thing is this slicing operation works. Now, one more important thing. If let's say, if you will write, this is a negative slicing. I have not. So if you will simply do this like this, if you will simply do A, simply -1, what it will give you? Let's first understand. It will give you. So let's understand how negative slicing works. Let me clarify you this thing first. So see, this is an array. Let's suppose this is my array. This is my array having value 10, 20, 5, 6, 11, 17. Let's say this is my array. So what happens? Let's change the color. If I will index this, it will get indexed in this way: 0, 1, 2, 3, 4, 5. But if you can index from the reverse direction, it will get indexed like this: -1, -2, -3, -4, -5, and -6. That means the index 5 and -1 both are same. Index 4 and -2 are same. Index 3 and -3 are same. Index 2 and -4 are same. So if you will write A -1, it is same as writing A5. You will get the same value. Whatever value you will get at this index position, you will get the same value at this index position. Whatever value you will get at this index position, you will get the same value at this index, because this is a negative indexing. And when we do the indexing from the reverse direction, from the opposite direction, we do the indexing in this way. So hope this is clear to you. Is this clear to you, Varun?
Yes, sir.
So have you understood this before? Do you have the clarity of this indexing thing before?
Yes sir, the list में पढ़ा है.
What?
Sir, it was in list also. This topic was in list also.
ये टॉपिक था लिस्ट में?
Sir, list में भी था, list में.
हाँ, correct. So, and the same thing is in array. So I suppose this is clear. Now let's move ahead. Now see what I'm going to do. If I write here, let's say this is my, let's suppose one very important thing that I'm going to, this is my array, fine. Now if I will write a, let's say 5, since we have understanding of this thing, what it means a5 semicolon, what it means? Please tell me, Varun.
Sir, it will print the numbers from 5th index till the last.
Correct. Now, what I'm going to do, if I will write this thing, what it means, this is my assignment operator. Equal to is my assignment operator. So whatever be the whatever value whose index starts from 5th, whatever value that is starting from 5 and going till end is getting assigned a value of 10. So to understand this, let's run this and see what I'm. Can you see here the value from starting from the 5th index till the end is has got the value of 10. In all those indexes, 10 get assigned. So this is how, this is also the assignment operator works in NumPy. We can do one more variable of this. Let's see, np dot arrange, arrange. Let's write this np dot arrange and let's write 5. Fine. What it simply means? It simply means 0 to 4. Now, if I will write, let's write a 5 from 5th index to end is equal to, let's write b, this thing, and let's write -1. So this is also a assign, this is also assignment, sorry, assign. So what it means, what it is, what I am asking, first I am let me write, first I am accessing the value from 5th index to the last index. So in A, so what is the value from 5th index to the last index in my A? 5, 6, 7, 8 and 9. This was my value in A. Matlab, this is an array. Let's understand this. This is an array. In this array, this 5 to the last means this thing. Now inside this B, what I am asking, what is my B? This is my B. This thing is my B. What I am asking, this my starting index, start index is 0, end is end, and I'm asking it to Give it a step size
Reverse
of
the.
-1. What?
It will reverse the array. It will reverse the array.
Yes, correct. It will reverse the array simply. So if it will reverse this array, what I will get? I will get 4, 3, 2, 1 and 0. Fine. This thing. So I'm assigning these values to this thing. Can you get? So instead of this 4, 5, I am assigning here. What I am assigning? 4. Here I am assigning 3. Here I am assigning 2. Here I am assigning 1. And here I am assigning 0. So finally, what I will get? Finally, if I will see my A, I will get 0, 1, 2, 3, 4. And after that, again 4, 3, 2, 1, 0. Do you understand this? Do you have any doubt here, Varun?
No, sir.
Fine. So let's see this. Let's run this. So let's run this and see A, because I'm assigning in A. So that's why the value of A will change. So I am getting 0, 1, 2, 3, 4, then 4, 3, 2, 1, 0. This is also one way of assigning. Now the next thing that I want to discuss here is called copies and views. This is called copies and views. So what this copies and views may do? So let me first explain you this one thing. See, when we were doing this slicing operation, inside this slicing operation, so let's suppose there was one array, something like this. There was one array. So inside the slicing operation, it creates a view on the original array. It creates a view on the original array. It creates a view on the original array. Fine. We can use np dot may underscore share underscore memory to check if the two arrays share the same memory block. To check whether the two array share the same memory block. But before it, let me tell you one more thing. So have you understood this? Now I'm going to erase this thing and let me tell you one more thing. Let's suppose there is one array. Let's say this is an array, and this array has got 1, 2, 3, 4, 5, 6, 7, 8. Let's suppose. And we have one more array called B. And let's say this B has got 2, 3, 6 and 8. Let's say. Understand this as an array, not as a list. So this array, why this NumPy is very much memory efficient also. This is one of the reason is also there. See, this array has got 1 to 8, 1, 2, 3, 4, 5, 6, and this there is certain memory location of all those elements which is present. These are having a certain memory location, memory address, and I am creating the one more array B, and this array B has all the elements 2, 3, 6, 8, which is also present in my array 1. So instead of creating a separate memory for this array, it will simply point towards the memory address of this array. It will simply point. This will point towards the memory. It will share the same memory address. Fine. So if let's say if this is one array and this is my another array, to make the memory much more efficient, so this is a way for the array to achieve the memory efficiency. So it will point towards the same memory location. But both are not same. Both are different arrays. Only the memory of these elements, since all the elements present in this array is also present in this array. So instead of creating a separate memory for all these elements, it will share the memory of this array. Have you got the point? What I am trying to explain you?
Yes, sir.
So same concept is we are going to understand here. Now, so what I'm trying to tell you here, so when modifying the view, the original array is modified as well. Fine. What it means? It is better to understand this with the help of code so that you can easily able to understand this. So let me write one simple code here. Let's write np.arange and write here 10. Fine. And let's write a here and let's run this. So I got this array. Now I'm creating one array B and I'm creating an array B from the array A only. So I'm using this thing with a step size of 2 and let's create this array B. I'm creating array B from array A. So this array 0, 2, 4, 6, 8 get created. So if I want to, since this is another array, B is my another array, 0, 2, 4, 6, 8, and A is my another array. Both are different array, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But whatever element is present in my B array is also present in my A array. So if you want to see whether these two arrays shares the memory location or not, so there's a way to check it. So np dot, you have to write np dot sha shares memory. If you will write shares memory, then you have to write the name of the array with whom you want to check. So first array is my A and second array is my, let's say, B. You want to check whether this array A and B share the same memory location or not. So if you will run this, you will get true. Because I have just now explained you, this is a internal functioning of the array. This is how the array actually internally works to optimize its memory efficiency. And these are different array, but still they share the same memory location. So let's understand very important thing in this case. Now, one very important case here. Let's see, since they are sharing the memory. So let's see if at the 0th index of my this is my V array, and at this location, 0th location, I am assigning something else. Let's assign 10 here, and let's see B. Now, what is my value of B? 10, 2, 4, 6, 8, because I have assigned a different value at my 0th index. So this is my new value. So, and what was my A? My A was this thing, 0, 1, 2, 3, 4, whatever thing, sorry, 0, 1, 2, 3 to 9. Now again check what is my B. Can you see, even the value of the, even though we modified only B, we have not modified A, we have modified B. Even though we modified B, it updated A, because both share same memory. That's why when it has updated, that value was also get updated. So this is one positive thing also, and one negative drawback is also there. So if you will if the two arrays will share the same memory location, so if you will update one, it will automatically update the second value. So let me write this thing here for you to remember. Even though we modified B, it updated A, because both shares same memory. Fine. Now let's see so how you can so there's one more concept called force copy. How you can force a copy. And if you will force a copy, that copy will not share the same memory address. So let's create one np dot arrange arrange. Let's create this array. I'm creating a new array, and what I'm doing, I'm creating a second array with this array only from the array 1. Same thing I'm creating, whatever I have created ever, same thing. See here, earlier I have created A, this same, and thereafter from A I have created this B, from A, and every I have created this B from A, and every element of B is also present in A. Now instead of this, till here everything is same, nothing has changed. Only here what I am doing, I am writing COPY. This is a copy. So when you are doing this copy thing, this is also called force copy. Force a copy. So when you will do this, and let's access this C, let's print. I am getting this 0, 2, 4, 6, 8. Fine. Now, if I will see np dot, now check the same thing, shares. Earlier when I have done without that copy and I was checking, it was where it was copies and views. So earlier when it was, I was checking shares memory a comma b, I was getting true because both the array share the same memory address. Shares the memory, not same, shares the memory address. Now this time again I am checking the same thing, memory shares memory a comma c, a comma c. If I will do, I will get false. Why I am getting false? Because whenever you do force copy, whenever you will force a copy, it will not share the same memory address. It will share a different memory address. And since it is sharing a different memory address, so this time, if you will do any changes in C, inside C, let's say I am changing the index of 0th index of C and I am assigning 10. And I want to see C, I am getting this. And let's say I want to see A, I will get, since A has not changed this time. So whenever you want that it should not share the same memory address, so you can force a copy. And in this way, if you will make changes in one, it will not impact the other array because it is not sharing the same memory. One more thing that I want to discuss with you today is, let me discuss this thing today at least. So what's the time? Let me check the time. Okay, fine. We still have a lot of time. So this is called fancy indexing. The name of this is called fancy indexing. Fancy indexing. Indexing. So what is this fancy indexing? So let's understand this fancy indexing. We can do fancy indexing with the help of this Boolean mask. We will also study here Boolean mask using Boolean mask. So how this works? Let's understand this here. Let's write one array np dot random dot rand int and 0 comma 20 comma, let's write 15. What it will give, what this thing will give, it will generate one array, it will generate an array between 0 to 20. It will generate 15 array, and that is, it will generate 15 random integer. And let's print it also. So I have got these many, I have got this array which is having these integer values, int values inside it. There are 15 in number, 3, 6, 9, 12, 15, 3, 15. Fine. Now, if so, this is my array. A is having this array is having these many elements. Now, mask is, let's create one variable called mask. And inside that variable, what I want, A, this modulo operator, this is called modulo operator, is equal to 0. What equal to 0? What it means? I am asking it whichever value of A whichever a is equal to 0, whatever value of it will divide each one of the elements inside this array a, each one of the element it will divide by 2, and whatever value will return 0, it will return me that value. So let's first run this mask, and then I will explain you this thing. Extract from let's go a, and if I simply do a, and then I will pass mask here, and then I will again print extract from a, and I will run this. I will get these two values. Let me explain you this thing. First, I am defining one variable mask inside this a modulo 2 means whichever value of a is completely divisible by 2. That means when a is divided by 2, it is giving me a remainder of 0. It is giving me a remainder of 0. It means that a modulo 2 means the remainder should be 0. So whatever value of a is divisible by 0, it will give a remainder of 0. That means it will give you a true value. So now inside this a array, inside this array a, I am passing this mask. So what it will do, it will check every value. It will take every value, each one of the element. It will take first, let's say it will take 9, and it will check, is this thing true or false? So this is false. Then it will check this is true or false? Then this will come out to be false. This will come out to be true. 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 This will come out to be false. This will also be false. This will be false. This will be false. This will be true. This will be true. This will be false. So false. So whatever thing that will come out to be true, it will return you that value. So can you see? I am getting this 8, 2, 0, 2, 8, and then I am getting this 10, 16. So only values that is getting, I am returning to be, oh, my charger is, let me, so it is returning me this, it is masking, basically it is masking all those values that is returning it to be false. It is only returning the values that is coming out to be true. This is the concept. This is also called Boolean mask. So now let's move to the next. We can also index with mask, indexing with a mask. This is one concept called indexing with mask. So let's understand this indexing with a mask. With mask. So if I write a, and then if let's say I will write mask, and if I will simply write -1, what it means? And if I will simply write a here, then what it means? It simply means inside this a, it will mask all those values, and whatever the masked value is, it will assign -1 to the masked value. So if I will run this code, see what I'm getting. Whatever masked value is there, it is assigning -1 in that place. Can you see? Whatever value here that was masked, so on all those values, I am getting -1. So whatever value is fulfilling this condition, a modulo 2 is equal to 0, in that place I am assigning -1. So this -1 is coming on all that values. In place of all that values, this -1 is. This is called this is also called indexing with mask. And no, this is not called indexing with mask. With the help of indexing with mask, we can assign a new value to my subarray. Now, if let's understand this new thing, A is equal to, if I write A is equal to np dot a range, that's right, np dot a range. And here, this time I am writing 0, 100, 10. Let's see. And if I will write this A, so, and if I will run this, what I will get? 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Because I am given the interval of 10, step size of 10. Now, if I write here, this is my A, fine, 0, 10 to 90. Now, let's say if I will write this thing, and I will give some index. Let's say I am giving the index 2, 3, this is my index value, 3, 2, 4, or let's say 2. So if I will write like this, what I am doing here, this is my index and I am repeating my index several times. This index value 2 is repeated here 3 times. 2, 2, 2. Similarly, I can also repeat some another index as many times as I want. If you run this, you will get this thing. See, at the second index, what is 20 is my value at my second index. So I am getting 20. At third index, 30 is my value. So I am getting 30. Again, second is coming. That means at second index, 20 value, again 20 is coming. At fourth index, 40 is value. Again, I have written 2 here at my second index. So again, this thing is repeating. So this is called indexing. So what we can call indexing can be done with an array of integers where the same index is repeated several times. Fine. This is what indexing can be done with an array of integers where the same index is repeated several times.
But that means it supports multiple indexes at the same time.
What?
Sir, array supports करता है multiple indexing at the same time.
I'm not actually able to hear you properly what you are saying. So can you please, if you will not able to speak, can you please type it in the chat box so that I can get what you want to say? Or it is better just we are at the end of the today's session, so it's 1 or 2 minutes more. So then you can ask a question. So I suppose, let me do one thing. This is one last thing that I wanted to explain you. This is how a new value can also be assigned. New values can be assigned. Assigned. So let's see. Let's suppose here we have an A, and let's say instead, let's say at index 9, let's suppose at index 9 comma at index 7, at these two indexes you want some another value, some values like 500. So if you will do this, if you will do like this, and if you will see A, see what happens. Can you see at 9th index and at 7th index, as these two index, this 500 get assigned. So you can even, by using this, you can even repeat this same index several times to get the value at that index several times in array, or you can even use this to assign some new value at that particular index. Let's say here I am assigning at 9th index and 7th index, I am assigning this value 500. So I am getting 500 at these two indexes. Fine. So I suppose this is all for the day. So let me save this, whatever we have discussed. Let me save this, and let me upload this thing in GitHub. So let's save this. So I have saved this, and let me upload this to the GitHub. Second station of NumPy completed. Fine, committed. Yes. Sync changes. Okay. Array supports multiple indexing at same time. This is, yes, you can say like that. Indexing can be done with an array of integers where the same index is repeated several times. You can you cannot say like that array supports multiple indexing at the same time. This is not a correct way to say, but you can say you can repeat the same index. You can repeat the same index is repeated several times. It is a correct way to say this. Because saying multiple indexing at the same time and saying the same index is repeated several times, it's it's like playing with a language. So there is a slight difference in the way you say. So it's better not to go with the, it's better to understand in this way, in the form of code, because for guys who are doing programming, it's always good to understand the thing, or it is always better to understand the thing with the help of code. So I have already uploaded this, or whatever changes I have made to the, now you can share your experience, Mr. Varun, and so that we can wrap up for the day. So let me stop sharing my screen and let me open my video now. So you can also unmute and So how was your experience? What you have learned? Is everything?
Am I
And
audible?
yes, yes, you are audible. Yes, you are audible.
सर आवाज क्लियर आ रही है सर?
हाँ हाँ, आ रही है। आप हिंदी में बोलिए, कोई दिक्कत नहीं, आप हिंदी में बोलिए।
सर अच्छा रहा सर, आज का भी समझ में आ गया था।
कल का भी आ गया था समझ।
हाँ सर।
तो अभी 2 सेशन, 2 से 3 सेशन मेरे ख्याल से और मैं लूंगा। नमपाई ये बिल्कुल ही बेसिक्स चीज़ें, फर्स्ट ऑफ ऑल की बेसिक्स चीज़ें कंप्लीट होना चाहिए। एंड देन देखते हैं और क्या कर सकते हैं। तो कल का सेशन जैसा रहेगा मैं आपको फिर बता दूंगा, और हम लोग कम्युनिकेट कर लेंगे। सो गाइस, ये वरुण जी के डिमांड पे ये सेशन हो रहा है नमपाई का, और इसको हम कंप्लीट करेंगे अच्छे से। और भी जिन भी लोगों का जो भी डिमांड है आप दे सकते हैं। आई विल ट्राई टू फुलफिल योर डिमांड, और मैं कोशिश करूंगा कि आपको जितने अच्छे से एक्सप्लेन कर सकूं। मेरे लिए ये सौभाग्य की बात होगी। और वरुण, आप आए, बहुत बहुत धन्यवाद आपका। आप पढ़ते रहिए और आप काफ़ी अच्छा करें आपके आने वाले एग्ज़ाम के लिए। बहुत बहुत आपको शुभकामनाएं। आप खूब तैयारी करें, अच्छे से पढ़ाई करें और अच्छा रिजल्ट करें। यही मेरी शुभकामनाएं हैं, यही मेरी आशा है।
थैंक यू सर, थैंक यू।
ठीक है।
थैंक यू वेरी मच सर, सर आपने बहुत मदद की है।
नहीं, मैं आपको करता रहूंगा, मेरे से जो भी हो पाएगा मैं डेफिनेटली करूंगा आपको मदद।
थैंक
ये
यू
ऐसे
वेरी मच
लोगों को
सर।
मदद करने में बहुत अच्छा लगता है जो बहुत ही सिंसियर लोग होते हैं, जैसे कि आप मतलब जिस सिंसियरिटी के साथ आप टाइम से पहले क्लास में आए, पूरे क्लास में रहे, आपने पूछा, तो ये दिखाता है आपकी सिंसियरिटी। और मैं इसको बहुत रिस्पेक्ट करता हूँ, चाहे आप हो या कोई भी हो। तो जो भी आप तरह के लोग हैं, सिंसियर लोग हैं, मैं ऐसे लोगों को बहुत दिल से रिस्पेक्ट करता हूँ, और उनको मैं कुछ उनके लिए भी कुछ करना चाहता हूँ। तो मेरा ये छोटा सा कंट्रीब्यूशन है आपके करियर में, और आगे और भी बड़ा कंट्रीब्यूशन हो सकता है। ठीक है। तो ठीक है, चलिए फिर कल मिलेंगे हम लोग, या जैसा भी होगा हम लोग कम्युनिकेट कर लेंगे, और मैं कोशिश करूंगा कि आपका जो भी इश्यूज हैं वो क्लियर हो जाए। ठीक है वरुण, चलिए,
थैंक यू सर।
गुड
गुड
नाइट।
नाइट सर।
गुड नाइट, गुड नाइट।